Hello everyone. So in this problem we will draw Bode plot for output impedance. They have given that value of CB is greater than CL and ignore channel length modulation. Okay, so this CB is a blocking capacitor. So basically it will block your DC and it will pass your input signal. Okay, so it's a CB capacitance and this is your load capacitance. So we will draw Bode plot for this circuit. We can draw quickly, but we will give some time to analyze the circuit, and then later we can draw quickly. Okay, so let's analyze how this circuit will behave for different frequency range of operation. Okay, so now I have copied the same circuit. So for calculating output impedance, we will apply a test voltage and this is test current. Okay, so we know that we ground our independent sources. So this will be grounded. This is bias voltage. This will be grounded, and this is also input voltage is also grounded. So this uh, this is the way we calculate our impedance. Okay, so now we will see how these both capacitance will behave across different frequency range of operation. Now we know that our reactance is 1 by omega c. So it's inversely proportional to frequency and capacitance. Since this value is large and this is small, so for a given frequency, this capacitance will offer a low impedance. Okay, I want to say that between these two capacitance, CB will be sorted first. Okay, and after increasing much frequency, then CL will sort. Okay, so at lower frequency, both capacitance will be open, and as we increase frequency, CB will sort first, and after increasing frequency much higher, then our CL will be sorted. Okay, so what can be the possible condition or how the capacitance will behave? So I will show. Okay, now plot just we will analyze how the capacitance will behave across frequency. Now for lower frequency, both capacitance will be open circuit. Okay, so XCL and XCB will be infinite. Okay, now as we increase frequency, for some frequency range, both will still be open. Okay, now if we again increase frequency, now this blocking capacitor will start reducing its impedance. Okay, so now XCB will start reducing and XCL will remain open circuit, so it will be infinite impedance. Now after some frequency, XCB will be completely short. It will offer no reactance and XCL will remain open. Now this condition will remain sometimes some frequency range. So this will again XCB equal to 0, XCL equal to infinite. Now if we increase again frequency, XCB is sorted. Now XCL will start reducing. Okay, now we again if we increase frequency, XCB is 0 and XCL will also become 0. Okay, so what I did, I increased my frequency. Okay, for a low frequency range, both capacitance will be open circuit. Now I increase my frequency. Since CB is larger, it will start reducing its reactance. Okay, and after some frequency range, the CB will become completely short, but CL will still remain open. Now, after some frequency, higher frequency, CL will also start reducing its reactance. Okay, and finally, both capacitance will be a short circuit. Okay, so we also know that at t equal to 0, our capacitance is open circuit. At t equal to infinite, our capacitance is short circuit. Okay, so t equal to 0 is nothing but omega equal to infinite. So at this case, capacitance is open, and at t equal to infinite or omega equal to 0, our capacitance are short circuit. So same thing happening here also. Okay, so this is how our capacitor will offer reactance across frequency range of operation. Okay, so now use this condition and we will determine what will be the magnitude of our impedance. Okay, so for that I have copied the same circuit again. So what are the possible combination for true capacitance? So first CB, CL both open, then CB short, CL open, and finally CB, CL both open. So now we will use these three conditions. Okay, we can we could have directly started from here only. Okay, we can see the two capacitance will be 3, this condition we can directly have started from here only, but it's okay. Now in first case, when both capacitance will be open, so what will be the current here? This current is 0, this is open. Okay, and this is also open, and current here will be 0 because VGS is 0, channel length modulation is also 0, so R0 is infinite. So current going up will always be 0 in every case, and this capacitance are open circuited. So what will be the total output impedance here? It's simply 1 by Gm. Okay, it will be simply 1 by Gm. R0 of this transistor also infinite. So I will mark this point omega mod of Z out. Okay, so I will mark a 1 by Gm. Now I will use the second condition. Second condition CB short, CL open. Okay, so I will use in the same diagram. Now this is sorted and this is open circuit. Okay, now in this case what will be the output impedance? In this case this voltage, gate voltage is 0 volt, is sorted to the ground, so there will be a current here. Okay, this current will be 0 and this current will be directed to the ground. So what will be the that current? If I write a KCL equation at this node, so I out equal to V out divided by RF plus and this current. Okay, so what will be the this current? This will be Gm VGS. So Gm and VGS will be 0. Okay, so in this case V out by I out will be RF. Okay, now I will compare this magnitude to the this magnitude. So RF obviously will be greater than 1 by Gm. Okay, so I will mark a RF here. Now in third case, both are sorted. Okay, when both capacitance are short. Both capacitance are short circuit. So again, GMVGS, this current will be internal current of MOSFET will be 0, and this current will be 0. There is no path. So what will be the that impedance? Now if we look from here, this giving a short circuit path. So Z out will be simply 0. Okay. In third case, our Z out will be 0. Now I will mark this also. So let me draw here. So for first case I got 1 by Gm, and then I got Rf, and then I got 0. Now I will simply match this. Now you tell me which point reflects which. So here we are going our magnitude increasing. So this point will be a 0. Now we are going from here to here. So our magnitude is decreasing. So this point will be a pole. Now from here to here, again its magnitude decreasing. So it will be again a pole. Now we will calculate our pole locations. Okay, we got our magnitude 1 by Gm. This is Rf and this is 0. Now we will get our pole locations. Okay, now I have copied the same circuit. We will see exact location of omega z, omega p1 and omega p2. So omega z, which capacitor will give omega z? This capacitance is lower value, so this capacitance is still open circuit here. Okay, so that won't give a 0, even though you will check whether this capacitance will can give a 0 path. So you will put omega equal to 0, then it will be open, so surely it's not a 0. And when you put omega equal to infinite, then only it will provide a 0 impedance path, and your output impedance is 0. So definitely CL will not give a 0. Now we will calculate 0. So output impedance is Z out equal to V out divided by I out equal to 0. So it means V out equal to 0. So there must be a direct path, direct connection between V out and ground. So this won't give 0. So which will give? Definitely this path will give. Okay. So this impedance of this path will be 0. Then only that node is directly connected to this ground, and V out will be 0. So how a series impedance of R and C will be 0? So that will be R minus 1 by J 1 plus 1 by J omega is equal to 0. So this will give omega Z equal to 1 by RF, and this is CB. So this will be RF into CB. So this is our 0 location. Now omega P1. So what will be the omega P1? Z out will be infinite. So I out will be 0. So in this case, again this capacitance will still be open. Okay, this capacitance will still be open, and our I out is 0. So this current is 0, upper current is 0, and this current is Gm VGS, and there will be one current here. Okay, so we will apply a KCL here, and we will equate this current to this current, and sum will be 0. So what will be the RC current? That will be V out minus Vg by Rf plus Gm Vgs equal to 0. Okay. So this current will be V out minus Vg divided by Rf, and this current will be Gm Vgs, and this same current will be Vg by reactance of this Cb. So I can also write this as Vg into S into Cb plus Gm Vgs equal to 0. From here, source voltage is 0, so that will be only Vg. Here we can get omega P1 equal to minus Gm1 by Cb. So this is our first pole location. Now let's calculate the second pole location. Now in this case, again for pole our output current will be 0. Okay, and now at this pole location our this capacitance will be short circuit. Okay, this capacitance is short circuit, and this capacitance will be remains. Okay, it will offer some current, offer some finite impedance. So what will be the KCL here? That will be, so if this is short, so this VGS is 0, so there will be no internal current. This current will be 0, and this current will be V out by Rf, and this current will be V out into SCL. Now we will add both current, and it will get to the 0. So I out equal to V out by Rf plus V out into SCL equal to 0. Okay, so this will be, from here omega P2 will be minus 1 by Rf into Cl. So final Bode diagram will be, this was our magnitude varying across frequency range, and this was our locations. So this is 1 by Gm of Cmos, this is Rf, this omega z equal to 1 by Rf into C blocking capacitance, and this omega P1 equal to Gm1 by Cb, and this one is omega P2 equal to 1 by Rf into Cl. Okay, so this is our complete Bode diagram for our output impedance. Okay, so this will look like some lengthy process. You can directly use this concept. I just explain how actually we do internally. We do these things only when we use direct analysis. So you can use direct analysis like by just saying this circuit. There is two independent capacitance, so there will be two poles due to this capacitance, and there is one 0, so that path will give a 0, and you can apply KCLs for different cases. Okay, for since both pole locations are at distant, so you can treat separately. Okay, you can treat one at a time. So by that way you can also calculate, that will give the same result. So, okay, please let me know if you see any wrong analysis or you have any doubt. Okay, thank you. Bye.